Hi class. So we'll continue with geometric um, series. We had just finished looking at geometric sequences. So just to recap, the geometric sequence was where you had a term of numbers that were off by the same ratio, the same essentially the same multiple. Okay, and they could be positive or they could be negative. So now what we're looking at when we talk about geometric series is we're looking for, instead of looking for a particular term here, now we're looking at what the sum of the series is going to be. So you've got a couple of equations here that allow you to do that. The first one, so the letters mean the same thing, T1, R, and N, and Sn simply means the sum of a particular nth term. Okay, so that equation is there, and then there's another one that allows you to do things that has in terms of R, Tn, and T1. Okay, so let's figure out how to use these equations. So here's a series where, again, we're looking for the sum, and it starts us off here with the first three, and it wants us to find the sum of the first 10 terms. So one way to do this would be to just continue the pattern and then add everything up. And imagine if you were doing something that had 1,000 terms that you wanted to get the sum on, right? So we don't want to waste that amount of time doing that. Instead, we can use the equation. So here what we're doing is we're solving for the 10th term. The sum of, and so when I say the sum of the 10, I'm talking about of all the 1 to 10 values added up. Okay, T1 is the first term, so that would be 4. R is, so let's look at how are these values in this series relative to one another. And so what you notice here, 4 to 12 is a multiple of 3, 12 to 36 is a multiple of 3. So R is going to equal 3, right? So that's going to be 3 to the power of 10 minus 1. And then at the bottom there it's R minus 1, so that's going to be 3 minus 1. And so use your calculator to verify this. In the bracket here you're going to get 59,048. Okay, all over 2, and that's going to give you 118,096. Okay, as your answer. Okay, so now that one they gave us the first 3 terms. In B they're giving us some other information. They're giving you the R value and the T1 value. Okay, so let's do the same thing here. Okay, so the 10th term. So now what I'm going to do is I'm going to use the second equation. So in terms of how do I know which equation to use, the way I figure that out is by what I've been given, which of the 2 equations has the information necessary. Okay, so because I know what R is in T1, I can use the second equation here. Okay, I can't yeah, so I think I might be able to use the other one as well. Let's have a look here. So you have T1 and you have R. And yeah, so you could use the other one too. Okay, so this is going to be 5 1/2 to the power of 10 minus 1 over 1/2 minus 1. Okay, and so that's going to be 5 1 over 1024 minus 1 over the negative 1/2. Okay, so you're just dividing by negative 0.5, and so when you work this out, you're going to get 5,115 divided by 512. Okay, so if you want to leave it in in a fraction form, you can put that in lowest terms. Or if you want to put that as a decimal answer, you can just do the division. Okay, I don't know if it works out to a clean number or not. Let's look at example 2. So here again, we want to find the sum. Now notice the way the sequence is written here. They give you the front end with the first term and a couple other terms, and then they give you the final term as well. But the problem here is I don't know how many terms there are, right? Because there's a gap in between. So what we'll do here is let's take the information that we have. So you've got 1 over 27, that becomes 1 over 9, that becomes 1 over 3. So what's happening is the values are getting bigger. Okay, so 1 over 9 is bigger than 1 over 27, and they're getting bigger by a multiple of 3. Okay, your nth term, Tn, is 729. Again, we don't know what n is. And your first term, we do know, is 1 over 27. Okay, so that's the information that we have. And so, again, look at which of the two equations we can use to make that work. So the sum here is going to be 3. Okay, so that's your R value, multiplied by Tn. So we're using the second equation there, 729. And then subtract that by 1 over 27. Okay, and then that's going to be over 3 minus 1. And so this is going to be 29524 over 27. Okay, so again, you can put that into lowest terms, or you can just leave it the way it is. Or you can write that out as a decimal. So have a look at which way the question is framed in terms of how they want you to put the answer. Okay, next one here. Same idea. Sn. Okay, your R value here is going to be minus 4. Okay, so like 4 becoming negative 16 means you multiply by minus 4. Okay, your nth term here is negative 65536. And then subtract that from 4. Divide that by negative 4 minus 1. And that's going to give you negative 52428. Now, sometimes what we say is is you have a series that's infinite. That means it just keeps going. And so it depends what's happening in that series. There's two possibilities. The series can either be what we call convergent or what we call divergent. Okay, so let's look at what those two terms mean. If it's convergent with an infinite number of terms, that means the sequence of partial sums approaches a fixed value. So think of this in terms of like when we talk about an asymptote in a graph. Okay, so if we say the asymptote is y equals 0, that means that you never touch 0, but you get closer and closer to 0. So it's approaching a fixed value, so like 0. Okay, if it's divergent, this means that a partial sums does not approach a fixed value. So like if we went 2, 4, 6, 8, and we just kept going, we're not approaching any fixed value because our value just keeps growing. Okay, so whether it's growing or it just keeps getting smaller, it's not approaching some type of asymptote. So what we have here is an equation, and that it's basically saying the sum of an infinite, that's the infinity symbol, is equal to T1, 1 minus R. And this is for a specific set of R values. Okay, so what this is basically saying is your R values have to be such that the only one that you're able to calculate can be convergent. Okay, so this is the one that you can use this equation. For the divergent one, you cannot calculate. So how do you know if it's divergent or if it's divergent, convergent or divergent? You're looking to see if your R value is between -1 and 1. Okay, so that's how you can tell if it's convergent or divergent. Okay, so let's look at this one here. So T1 is 1. And what's going on with R? So how do we go from 1 to -1/3? We do that by multiplying by -1/3. Okay, and so -1/3, that is between -1 and 1. Okay, so because of that, this is convergent. Okay, and because it's convergent, we can calculate it. Okay, so the infinite sum is going to be 1 over 1 minus -1/3, which equals 1 over 4 over 3, which is equal to 3/4. Okay, so that's so again, think of that as sort of like approaching an asymptote. Okay, so that's a fixed value. Okay, let's look at the next one here. So 2, -4, 8. So here T1 is equal to 2, and R is equal to -2. So -2 is beyond that range of being between -1 and 1. So this one here is going to be divergent as a result. Okay, and because it's divergent, you have no sum. Okay, so you can't calculate it. All right, so that takes us to the end of the unit. I'll stop there, and now you can work on the corresponding questions.